Okay, let's start. So the topic of today's video will be linear non-homogeneous PDE with constant coefficient, continuing from the last videos. And today we will be discussing the case when the right hand side gxy of our PDE is non-zero, and we will find a general method to perform the particular solution for that equation, right? So let me write the PDE. Okay, consider f d comma d dash, and here we had z is equal to g x y, and that was our equation number a, if you remember, right? And since for this right hand side it is a function of x and y, it is non-zero, hence we have to find the particular solution for it. And as in our last videos we have seen that there are some methods to find the particular solution corresponding to this gxy, but here in this video we will be deriving a general formula to find the particular solution, and that will work in all cases, right? As long as this fdd dash is expressed as a product of linear factors, right? Means this general method has some limitations, right? I will tell them later. If f d comma d dash, right, is expressed as the product of linear factors, that is this fdd dash, it is factorizable as d minus m1 d dash minus alpha 1 d minus m2 d dash minus alpha 2 and up to d minus mn d dash minus alpha n, z is equal to g x comma y, right? And I have assumed that this is a nth order partial differential operator, so that's why I have written n factors, right? So the general method, I am giving the general method to find particular solution, right? Okay, and what is that method? 1 upon p f is equal to 1 upon d minus m d dash minus alpha, and here we have g x comma y, right? Then the method says that, right, there is a formula which is like e to the power alpha x integral e to the power minus alpha x g x comma c minus mx dx, right? So this is the formula we will be going to derive, right? And this is very much similar to the general formula which we have derived in our last videos, where this alpha was 0, means when this factor was a homogeneous factor, right? This is obviously a non-homogeneous. If alpha has some non-zero value, this will be a non-homogeneous factor, right? And if you remember that for alpha is equal to 0, we have some formula already, right? So the proof of this formula, I am going to prove this proof, right? So consider a differential equation, partial differential equation of the form d minus m d dash minus alpha times z is equal to g of x comma y. And you know why I have taken this PDE, because taking this particular solution as a z, right, and then cross multiplying, I will be getting this kind of equation, right? And it can be written as dz will become p minus md dash z will become mq, and that will be alpha z taken on the right hand side, alpha z plus g x y, and this is a very familiar PDE, Lagrange's form PDE, Lagrange's form, right? And the subsidiary equations are given by dx upon the coefficient of small p, that is 1, dy upon the coefficient of small q, that is minus m, and dz upon this right hand side function alpha z plus g x comma y. These are called Lagrange subsidiary equations, right? And then taking the first two ratios, these two ratios, first two, and then integrating on both sides, and then I will be getting something like taking first two ratios, I will be getting y plus mx is equal to c, where c is a constant of integration, right? Okay, right. Taking first and third, taking first and third dz over alpha z plus g x comma, right, x comma y, but I don't need y here because we have to integrate with respect to x and z, and since I do not need y here, then I should replace y by c minus mx, c minus mx, and now cross multiplying it, I will be getting some equation like dz upon dx, dz over dx, and then it will be minus alpha z is equal to g of x comma c minus mx, right? And you are familiar with this equation. This is a linear ODE, right? Ordinary differential equation of first order and first degree, of first order and first degree, right? And you know that how to solve it. You write particular integrating factor, that is given by e to the power integration of p dx, and what is p? This is minus alpha. You can compare this with the standard form of linear ODE of first order, dz by dx plus pz is equal to capital Q, right? Then integrating factor, or should I write the solution directly? You can find the integrating factor, that will be e to the power integration minus alpha dx, then it will become e to the power minus alpha x, right? And then I will write the solution, that will be z times into e to the power minus alpha x. I am writing that directly, z times e to the power minus alpha x, that will appear here, okay, and integration of integrating factor multiplied by this right hand side function, e to the power minus alpha x g x c minus mx dx, right? And do not write the constant of integration because we are finding the particular solution, which is a constant free, right? So this is the proof, and I hope that you know how to prove it. You know how to solve a linear ODE with the of first order, right? Okay. So this is the proof. Okay. Then using this general method, right, we will find the particular solution. But notice that what do we need? We need precisely a factor of this form. Means this is a kind of non-homogeneous linear factor, right? And it is not the case that every time this FDD dash is factorizable into linear factors, as we discussed in our last video, that FDD dash may be expressed as a product of linear factors or may not, right? If it is expressed as a product of linear factors, then this method will definitely work, right? So it has some limitations too. Means FDD dash should be expressed as a product of linear factors, right? And this particular solution, right, this is for one linear factor, and if there are two linear factors, then it should be applied twice. We'll see that in numericals. Okay, let me highlight this formula because we will be going to use this, right? Okay, and then taking first example number 1, d plus d dash and d plus d dash minus 2 z is equal to sine of x plus 2y, right? Okay, so first thing is that we are already given this FDD dash in factorized form. That is what we need, right? Okay, solution, d plus d dash let and d plus d dash minus 2 z is equal to 0, means taking the right hand side as 0 to find the complementary function. You know that complementary function is always found by equating this f d d dash z is equal to 0, right? Then I will get complementary function. Therefore, complementary function, right, that is given by f1 for this factor, that will be y minus mx, y minus x, okay, and for this one we will have e to the power 2x f2 y minus x, where f1 and f2 are arbitrary functions. So this is the complementary function, and particular solution, that is 1 upon d plus d dash minus 2 and 1 d plus d dash. Okay, I have used the commutative property here. I have written this factor first and then d plus d dash, which is a homogeneous factor. You can see that both are first order partial derivatives, so this is a kind of homogeneous, right, and this is non-homogeneous. So writing the homogeneous first, and the right hand side is actually sine of x plus 2y. So first I will be solving this thing, solving for this, right? You can use this formula directly, and the good thing about this formula is that it works even for alpha is equal to 0, means if alpha is equal to 0, then it will become a homogeneous factor, right? So it is a more general form. Okay, so you can use this formula here where alpha is taken as 0. The formula will give me 1 over d plus d dash minus 2, and that will be e to the power 0x, okay fine, that will be 1, and e to the power minus 0 is 1, and then sine of x plus 2 times what, x plus 2 times y plus x, sorry, c plus x, c plus x dx, where I have substituted y is equal to c plus x according to this rule, right? Now this will be, I think, sine of 3x plus 2c. Okay, then integration will be minus of cos. That will give me 1 up over d plus d dash minus 2, and integration of sine is minus cos. Then this minus will appear here. Okay, then it will become cos of this thing, and 2 cos 3x plus 2c, and upon 3 should be here by 3. So I am writing here 3. Okay, right. Now replacing c by y minus x, that will become minus 1 by 3 d plus d dash minus 2, and it will become cos 3x plus 2 times of y minus 2x, that will become x plus 2y, right? Okay, now I have operated this 1 by d plus d dash on this sine function, and now I have this, right, d plus d dash minus, which is a non-homogeneous operator, so I have to take alpha is a non-zero here, right? So applying again this formula, is equal to minus 1 by 3, and since I have alpha is equal to 2 here, then it will become e to the power 2x, right? And inside integration, that will be e to the power minus 2x, right? And then this function cos x plus 2 times, and this y will be replaced by c plus x, right? C plus x dx, and I have to mention what is y is equal to c plus x. Okay, now this will become minus 1 by 3 e to the power 2x, and integration e to the power minus 2x, and then it will become, I think, cos 3x plus 2c dx. Now it is all about integration. Now we have exponential function multiplied by trigonometric function, and the long way is that you assume this integral as capital I, then you apply by part twice, and then we'll get the answer, or you can remember the formula If you remember the formula directly, then the calculation will be short, right? So I'm writing that shortcut formula, and that is use this formula integration e to the power ax cos bx dx is equal to e to the power ax upon a square plus b square, and here we have cos a cos bx minus, no, not minus, it should be plus, yes, b sin bx. This is the formula we will be going to use this time, because otherwise the evaluation of the integral will be lengthy. Okay, so I'm putting a hash on it. Right, now use this formula. That will give me minus 1 by 3 e to the power 2x, and notice that in place of a we have minus 2, in place of b we have 3, right? Or you can write it as bx plus c. Okay, fine, that's fine. We have chosen c is equal to 0 in this formula, right? Then it will give me e to the power ax, that will be minus 2x upon 2 square plus 3 square, that will be 9 plus 4 13, and inside bracket I will be having a, my minus 2 cos bx, that will be 3x plus 2c, then b, what is b, 3 sin 3x plus 2c. Okay, fine, right? And then putting value of c back. What is the value of c? That is y minus x. We will replace this c by y minus x, and that will ultimately become, I think these two will cancel out, that will give me minus 1 upon 39, and this will become minus 2 cos, and c is replaced by, since y minus x, so that will become 2y minus 2x, so x plus 2y, x plus 2y plus 3 times sine x plus 2y. So this is the required particular solution. Okay, then complete solution will be given by, therefore z is equal to cf plus pi will be the complete solution, right? Okay, so taking another example, example number 2, right? And let me write d cube minus e d dash square and minus d square plus d dash z, right? Okay, and the right hand side I will take x plus 2 upon x cube, right? Okay, now focus on the left hand side operator, that's f d dash. First it should be expressed as a product of linear factors, because otherwise this formula will not work. Okay, then trying to factorize it, let d cube minus d dash square minus d square plus d dash z is equal to 0. Searching the solution for the right hand side is 0, and may I factorize it? Should I take, yeah, d can be taken common, yes, or I will take d common, then it will become something like d square minus d dash square minus, it will become d, yes, plus d dash, yes. Okay, then d, applying formula on these two, I will get d minus d dash and d plus d dash, and taking negative common out of them, d minus d dash. Okay, z is equal to 0, and I think d minus d dash, then d plus d dash minus 1, z is equal to 0. This will be the final equation, right? Yes, and writing the complementary function for this, complementary function is for this one, d we have only y plus 0x, right? f1y, and for this one I will be writing e to the power, since alpha is absent here, d minus md dash minus alpha is absent, so e to the power 0x. Okay, fine, f2 y plus x, and here we have alpha is equal to 1, it will become e to the power 1x, and then f3 y minus x. This is the complementary function containing 3 arbitrary functions, right? And now the important point is to find the particular solution. right? And see the right hand side, x plus 2 over x cube, okay? And or you may write it as 1 upon x square, 1 upon x square and 2 over x cube, right? And the important thing to notice is that you cannot apply any of the previous methods we have discussed so far, because this is not a form of x to the power m multiplied by y to the power n, right? Means when you expand this f d d dash in ascending powers of d by d dash or d dash by d, even that formula will not work here, right? I will tell you how, right? So applying this general method, particular solution is equal to 1 over here are my factors, these are my factors, okay? Now giving the preference to the easiest factor, I will write d here, the easiest factor, then this homogeneous one, okay, d minus d dash, and this non-homogeneous, I will treat it at last position, okay? And here I have my function. What is my function? 1 upon x square plus 2 over x cube, fine. And now since d is present at the first place, then operating 1 over d, 1 upon d is actually integration with respect to x, and then 1 over d operated on this means integration of this thing, that will give me 1 over d plus d dash minus 1 d minus d dash, and then 1 over d operated on this will give me minus 1 upon x, right? Integration of 1 upon x square, and 2 upon x cube will give me minus 2 over x cube, x minus 3, x minus 2, 2, yeah, 1 by x square, okay, right? So this will be my function after integrating it, okay? Now here comes the operator d minus d dash, 1 over d minus d dash, and this is a homogeneous factor, right? And you can apply this formula also. Here is the formula, I have rubbed that, no problem. Is here alpha is equal to 0, I will write it as 1 over d plus d dash minus 1, and see d minus md dash minus alpha, alpha is 0, so e to the power 0x, that will be 1, integration e to the power minus 0x, again that is 1, and this function, but this function gx comma c minus mx, and what is that c minus mx? That is actually y replaced by c minus mx, and luckily this time I don't have y, right? So I will not care about that y, I will directly write it as integration of minus 1 upon x minus 1 over x square dx. I hope you understand, right? Because alpha is equal to 0, right? And there is no y in this, so ultimately it will be like this integration, okay? Then it will become I think integration of this will become 1 upon log x, okay, and that will appear log x in the calculation. 1 over x square plus 2 over x cube, okay, fine. Then integration of this will be minus 1 upon x square, differential of 1 upon x square, fine. Okay, now operate. That will become 1 over d plus d dash minus 1, integration of this will be minus log x, and integration of this will be plus 1 upon x, and note that we have this log x here, and I have to perform integration on log x, right? Okay, log x. Now see this, or should I take minus common? If I take minus common, then it will become minus here, right? Fine. Then I will be going to use the formula on this operator, right? Okay, so applying that formula, minus will appear outside, e to the power alpha x, my alpha is equal to 1, then it will become e to the power x, integration e to the power minus of x, and then my function log x minus 1 upon x and dx, and note that again we don't have y here, so there is no need to replace y is equal to c plus mx, because y is absent, so ultimately everything will be in x and there will be no constant, right? And that is a good thing. But the problem is that how to integrate this, right? Because I have exponential function and this log x here, and even this is more difficult. Exponential function multiplied by 1 upon x, and integration is difficult, right? So I think that if I see that the differentiation of this will be no, okay, minus. Should I take minus inside? Okay, minus, and it will become plus, minus plus. Okay, and yes, okay. And if you remember this formula, use this result, and that result is integration. You have used this result in your higher secondary course. This formula from integration, e to the power, we have two formulas, e to the power x, and we have fx plus f dash x dx, that is actually equal to e to the power x fx plus c, constant of integration. I will write it as capital A. Okay, one is this formula, and the other formula is second, integration e to the power minus x. If we have minus x here, then this formula gets slightly changed, and that is small change appears, minus of fx plus f dash x dx, and the answer e to the power minus x fx plus capital A. So rely on using this direct result rather than applying integration by parts, right? So I will be using this formula, and you can verify it on your own that if you apply the by parts on this part only, right? Okay, then I will show you how it comes, the proof for second. I think you have used this formula many times, but this is new. Okay, so I am showing the proof of this, how it comes. Take left hand side of this thing, proof of this thing. Okay, proof. Let me write integration e to the power minus x fx, and here I have minus, plus integration e to the power minus x f dash x dx, right? And if I take this as the first function, fx as the first function, fx, and then e to the power minus x dx. Now I will apply rule of by parts on this, taking u as fx and second function v as e to the power minus x. Then I will have minus first function as it is, integration of second function, that will be e to the power minus x upon minus 1, and then minus, then inside integral sign, differentiation of this function f dash x, and integration of e to the power minus x upon minus 1 dx, and here I have plus e to the minus x f dash x dx, right? You can see that I applied rule of by parts on this first integral only, leaving that second as it is, right? And you can see that this minus goes inside and will plus minus, and these two integrals will cancel, right? I will be having something like e to the power minus x fx plus constant of integration. If I write plus a here, constant of integration. Okay, so this is equal to right hand side of this formula, right? So you should know the proof of everything you are going to use. So this is a small proof for this formula, right? And I will be using this formula here. Okay, so should I write the answer directly? What should be the answer? Is equal to, using this formula, e to the power minus x, yes, multiplied by fx, and fx is actually log x if you compare these two results, because differentiation of fx is 1 upon x, right? You can compare this integral with this formula. Now it is direct, fx will be log x. So this is my particular solution, and then solution will be z is equal to cf plus ps is solution, right? So this is it for this video, and this is the last topic of linear non-homogeneous PDE. In the next video we will be considering some general PDE, means that will be homogeneous or non-homogeneous, that will actually consist of solving a PDE using Charpit method. That will be the next topic of our video. So for this video, thank you so much.